Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, I hope you're doing fantastic. This is Michael with Programming Electronics Academy, and I really appreciate you tuning in this week. This week's guest is Eirik Sverd. He's from Norway. He's a student in college right now, and he's studying automation. And he's done some really interesting Arduino projects. And he's going to share those projects with us, so I won't talk about them right now, but we'll be describing them in detail here. I really enjoyed this conversation, and Eirik has done some great work documenting his projects, so if you want to check those projects out online, we'll make sure to have links in the show notes. All right. Without further ado, let's go ahead and jump into this talk. Well, Eirik, thanks so much for joining me today. I appreciate you taking the time out of your day to talk.
Oh, yeah. Thanks for having me, Michael.
I found out about what you were up to through Instructables. You made quite a few Instructables, and the Arduino ones you were making kind of caught my eye. They're pretty neat, and that's why I reached out to you. But before we talk about those projects, I wanted to get to know just a little bit about you, kind of maybe your background and what brought you into working with Arduino and electronics and stuff.
Yeah, sure. So right now I study automation engineering, actually. So that's very much relevant to like programming and microcontrollers, all of that. But I started with studying business economics, actually. So quite the opposite of engineering. I had always been interested in electronics, where I did like some basic stuff with the LEDs and stuff like that, but not the advanced stuff like integrated circuits and programming, all that stuff. I was kind of scared of programming because it always seemed so scary when I saw it online and everything. So what happened was I actually was really lucky and won a Arduino starter kit from Make magazine, which contained all like Arduino, servo, sensors, everything I needed to get started. So I won this kit by submitting an ID to work with, and when I got this, I just it removed all my barriers right to start programming and start learning Arduino. So I just had this kit. Started watching a lot of tutorials online, everything, and sort of like hacked together pieces of code, very much spaghetti code in the beginning. And from that, I guess just the interest grew. And actually, I dreamt of becoming an accountant because my idea of fun was pouring through massive amounts of data in spreadsheets. But you probably read the Harvard report on jobs at risk for automation that came out when I think it was second year business economics, and that along with my growing interest in electronics and programming just convinced me to make the switch, start studying automation engineering instead.
Yeah, that's impressive. And I know the kind of kits you're talking about. They just come packed with a bunch of neat stuff to start kind of playing with. So how did you,
exactly.
I guess you mentioned you kind of got online, started looking at some different tutorials and stuff. What type of programs were you starting with? What type of stuff were you doing with that kit when you just got it, out of curiosity?
Yeah, so first of all, it was just what is programming? How can I interact with the physical world through these microcontrollers? So just basic hello world programs, blinking LEDs, playing around with digital analog signals and different delays, the kind of stuff every beginner goes through with these kind of projects. But what I think sort of made a difference for how deep I delved in the beginning was I really wanted to control these remote controlled sockets I had. The kind of remote controlled sockets that you can buy with a remote. Mm-hmm. So I actually found on eBay really cheap from China, I'm talking $1 or something, these transceivers that could let me decode the signals from the RF remotes. And then when I had decoded them, I can just write regular Arduino code to send my own signals. So I really wanted to do something with home automation. So like within a month of getting my first kit and the sensors I needed, I had like I could control my lights on my dorm room and stereo and everything from my phone. So that was so exciting, and I felt like I had really made something useful, instead of just blinking LEDs.
Right. I think it's so important to be able to do stuff that you can step back and be like, wow, that's pretty cool. It just feels good to be able to make stuff like that, I think.
Yeah, definitely. And have like one project that's guiding your progress, because it wasn't just plug and play at that stage. You have to like research what kind of code segments work with the stuff you got and everything.
Yeah, I know nothing ever seems plug and play when you're kind of doing something custom. And I'm constantly learning too. I enjoy learning a lot, and I just find that the building a project really brings out so many questions that inevitably you find yourself trying to answer, and that process just helps kind of, I don't know, make stuff make sense at times.
Yeah, and like sets you on a defined path. And then you get like these sort of milestones where you're reaching your goal if you like sort of maybe decode like in my example, I decoded a remote and I knew I was on the right track. Now I just needed to send signals from the phone. That was the next challenge,
Yeah, right. I know. It's like you got to celebrate those wins, because sometimes they can be hard to get. Sometimes I feel like I'll be busting my head against a wall for like a week or something on a project. But when there is a breakthrough and or a different path that I end up taking, I try to remember like, okay, see, I couldn't do that, and now I can. See, it is working out. But so I know the project you're talking about, because you did another Instructable about that, the RF signal one, and I tell you what, it was pretty sweet. Just so people listening can kind of get an idea about this project, would you mind kind of describing the project a little more in detail?
Yeah, so this project was sort of what I wanted to exist when I started my own project a few years ago. So what I published on Instructable and YouTube as well is sort of an introduction to easy home automation with these RF signals and like RF sockets. So you can buy pretty cheap in most hardware stores and electronic stores, usually like 3 pairs of sockets, like for mains appliances. So and with a remote. So these use radio frequency, usually 433 megahertz. And you can get really cheap from China and everywhere these transceivers to sort of decode or snap up the same signals that the sockets are receiving. So you just get these transceivers and download a already pre-made library and start decoding the signals. So now you know the information that the remote is sending out every time you press a button, and you can just write like regular logic to send the same information whenever you want. So you can hook up like a light sensor that turns on lights in your room if it gets too dark, or like a temperature sensor turns on your oven when a few hours before you wake up or when it's cold. And I actually hooked up one of these sockets to my electric kettle. So whenever I wake up, there's like always hot water ready for a cup of coffee, and lights on, everything. Made it much more easier to wake up in the morning.
That is so cool. So the socket that you're talking about, it's basically, it like just plugs into a normal wall outlet, and then into that you would plug whatever appliance, like a light or whatever you want to plug in.
Yeah, exactly. It's basically like a relay except it's like remote controlled relay.
Okay.
And I really like this because then I didn't need to mess around with mains voltage and wiring, because that's sort of in a dangerous zone. So I like to stay away from that if I can.
Yeah, absolutely. I only like my kids to work on mains. I don't like to touch that stuff. But so, and then basically that the RF transceiver that you're talking about, then it's replacing the controller that would normally come with those sockets.
Yeah, exactly. It's replacing the remote. So instead of you can just check away the remote, you have the information that the remote is sending out, and you store that in the Arduino and just program the Arduino to send out that information whenever you need on your conditions, right?
That is so cool. Now, with these, like, let's say you said usually like 3 come in a pack. If I got 2 identical packs, does each one have like its own identifiable ID? Is that it, or could I like step over them if I had a bunch of them in the same room?
Yeah, so I've tried a few different ones, and it seems to be up to, or it seems to be defined by the maker of the socket. So like I got two different 3 packs, and they have like slide switches on them to select channel 1, 2, and 3. So if I got 2 from the same pack, I can both set them to channel 1, and they will both trigger on the same signal. But if I got like 2 different packs and set both of these to channel 1, they both have their own remote, and both their own remote they respond to. So you can get as many you want and just like decode the signals from each one, and have like, you can outfit your whole house if you want to.
That is so cool. Now, the transceiver that you're using to replace the remote, what is the distance like? Is it as comparable to the one that comes with the pack? Is it better? Is it worse? What do you think?
Yeah, I thought it was actually a little bit better. I have no idea why. I guess it's because the transceiver had like a different antenna, either a different gain or range, or like a configuration, something like that. And it's radio frequency, so I don't think you can extend it on your own without or easily, but it's definitely something to look into as well.
Okay, now when you were talking about like sniffing the button presses from the remote, like immediately I was like, oh man, that sounds complicated. Or is it tough, or how do you like actually do that?
Yeah, luckily it was not complicated at all. This was my first real Arduino project, and I did it with basically no programming experience. So what you do is you find this pre-made library online, RTC lib, I guess it's the name, and it had basically done most of the coding work for you. And by the way, this is what I love about Arduino. You can already find so many resources online for what you want to do. So this takes the code and all the advanced code and puts it into pre-made functions. So import the library and basically say, okay, run decode function and write whatever information to serial terminal, and that's just what happens. The code is already defined to do all the hard lifting for you.
That is so cool. Now, does this library work on different frequencies? You mentioned yours was what, 433?
Yeah, that's the most common one, and you can get like I think it's 329 or 333 megahertz as well.
Wow.
So yeah.
And then you've got the serial monitor window open from the Arduino, and you literally just copy that, and then you can input that.
Yeah, exactly. It's literally just copy and paste. You know, the serial terminal spits out the information that's decoded, and just save it in like a notepad for reference later on and just put it in your Arduino code. It's as easy as that.
That is so cool. So what is the information? I'm curious. Like, is it letters and numbers? It's just ASCII code, right? I mean, or text?
Yeah, it's actually a bunch of different formats. You can get like decimal, binary, hexadecimal, and you just choose whatever you want. I think I chose hexadecimal because that just was the shortest string to save.
Gotcha. That is so neat. Yeah, and so then it sounds like the program. So once you've got that information, then you're setting up a new program. And is there a different library then that you use to send those commands?
Yeah, it's actually exactly the same library. So you just import the send function, and as a variable in the send function, you just input the code, the information you saved from the remote. So that is just sent whenever you want. So you call on this function whenever you want, like sensor conditions, whatever. If the light level gets too low, automatically call the send function with the information you just decoded.
Right. That is so cool. Now, so is it, and just to make sure I'm clear, I'm understanding correctly. So there's two separate steps. First, you're going to write a program. You're going to sniff those button presses, and you're going to use that information. You're just going to like copy it to a spreadsheet or something. And then you're going to write a new program, create those as like variables or whatever, or constants, and then use that in like the actual program you want to use to control whatever.
Yeah, exactly.
Okay, gotcha. That's cool.
Those two main steps, easy as that.
And it is worth noting you've posted. Have you posted that code on the Instructable?
Yeah, I got a link to the library, and I put up like 3 or 4 different example codes, so you can try it with like different sensors and conditions and everything as well.
Okay, fantastic. I think it's always good to, if you're trying to learn any language, I think it's good to look at other people's code and see what they're up to, and just try to follow it along as best you can. So if anybody's out there trying to learn how to use Arduino, I'd recommend checking out the programs. Speaking about programs, I was looking at the other program, or the other Instructable that you made, which was the no pump automatic watering station or plant watering system.
Yeah.
And I was looking at the code on that, and if maybe we'll come back to the code if you want to talk about that project briefly.
Yeah, sure. So one of the main challenges I was trying to solve with this project was like, how can I make like automatic watering without the pump, which is why no pump is like first in the title of the project tutorial. So the reason I didn't want to use a pump is they are usually noisy and require like special tubing. They might draw a lot of power, so you can't really power it from an Arduino. You need a transistor or relay as well, and they can sort of be pricey, like $10 depending on your budget. I'm a student, so I think
Nice.
It's a little bit expensive. So like my solution was to just use a regular hobby servo as well. These cost like $1 or $2 shipped from China, and what this does is it take like most kinds of flexible rubber tubing, like you could use with a pump, and the servo is stripped to this flexible tubing, and when a sensor says like it's time to water, the servo goes down and opens up the hose, and when it's done watering, it closes up or crimps the tube again. So benefits of this solution is, first of all, it's very cheap. Just one of these servo, they usually come in Arduino kits, so you probably have one laying around if you're into Arduino. It can use several different tubing sizes, and I actually didn't use a water tube at all. I just like snipped some extra wire I had laying around. I snipped a piece of wire and pulled out the copper strands inside, and I was left with this hollow plastic or rubber. So I just used that as a tube.
I saw that on the instructable, and I just couldn't stop smiling about that. I thought it was entertaining. When I was in college, I remember using a belt for a lock on my bicycle. I'd ride my bike around campus and I'd misplaced my lock, so I just used my belt. I thought, well, it's kind of like using a belt for a lock or something, but that was awesome.
Yeah,
I mean, talk about just using,
you know?
you got using what you have on hand. That was very creative, I thought.
Yeah, definitely. Necessity is the mother of innovation, Yeah, so this was also like really quiet. It only made noise a few times each day, and it was like for a few seconds. And it could be powered from a regular PWM pin on an Arduino, so no need to like mess with transistors or anything like that.
Now, you also have a moisture sensor that you're using, is that correct?
Yeah, that's correct. So it was, and that sensor is like not even $1 from China. It's, and what I like about it, it's like basically two pieces of metal. So you could just like substitute that for like two screws or two nails or whatever you want. It doesn't have to be one of these sensors.
Oh, that's cool. So basically you're reading the moisture level and you're using that as the input to determine whether or not to open the servo or close the servo, or I guess crimp the wire or not crimp the wire with the servo.
Yeah, exactly. So like the sensor just measures like the conductivity in the soil. So like conductivity increases when there's more water, and decreases if it's less water. So it's basically just measuring resistance. So you put this sensor, or like just two pieces of nails or screws, in series with a regular resistor, and you got a voltage divider. Feed that into one of your analog input pins, and that's how you measure like humidity in the soil.
Nice. That's a simple solution. That's cool. Now, so is it just fine tuning then to figure out like what's enough water? Because it ends up being based on time in some sense, right? Because you've got a tube of a fixed width and you only want so much water to fall. I mean, is it just kind of like fine tuning it once you've got the rig set up?
Yeah, it's definitely some fine tuning. I didn't fine tune like how long the water tube should be open. I only fine tuned like I measured when the soil was dry and when it was wet, and I stored those as constants in my Arduino code. So the sensor takes like average readings, like one or every, let's say, 5 minutes or something, averages all of that. And if the average value, which is then compared to one of the preset values, if one of those values like triggers the dry soil condition, it immediately opens up the water valve or servo, and now it doesn't measure in averages anymore. It just goes into constant reading with like I think it's 10 millisecond delay. So it's basically just measuring humidity constantly as soon as the valve opens, and as soon as the soil is wet again, it just shuts off that water flow. So no need to like fine tune or do math with the water flow. Just find out when your soil is wet and dry, store those two variables, and you're done.
So with the I was looking at the code, and it's only like 47 lines of code, which is pretty sweet. And I want to say you did a great job on the commenting, or at least I felt like, I mean, almost every line in there was commented, which I thought was just nice because helps me like follow along code. And
Yeah, thank
so
you.
anybody listening who wants to go and check this program out, maybe if you're not super familiar with Arduino code, look at this program that we're talking about specifically, because almost every line is commented. And I bet if you don't even know how to program, you'll still be kind of able to follow along and see what's going on here. I mean, it's C code or C++ code or whatever, but it's so well, I feel like you documented it so well or commented it so well that somebody can kind of get a gist anyway. So I definitely highly recommend this one to check out.
Yeah, thanks. I usually try to comment most of my code if I'm sharing online in tutorials like this one.
Yeah, it was, I thought a job well done. I know I appreciated it. So, as I was looking at the code, I noticed that you used the servo library to kind of write the servo into different positions. And, I'm just curious, when you're using that servo library, after you've written a position, does the servo just mechanically hold in that position, or is there does it require that the servo constantly be told to hold in that position? Does that question make sense?
Yeah, it makes sense, and it's yes and no. The servo can hold that position, no worries. So if you turned off the power, the servo would still hold exactly the same position. But the way the PWM signals from the Arduino work is they are constant. So you could just use a transistor to switch on and off the servo whenever it's not in use, which is most of the time because it's not watering for most of the time. But as far as I understood the servo library, it sends continuous PWM signals.
Gotcha. Yeah, so definitely like that code. I really enjoyed it. So I think it's awesome that, you decided to study automation. What's it like? What's it like studying automation? What does it look like for a student? What types of classes do you take? And is it hands-on like the stuff you're doing now, or is it not so hands-on, or I'm just curious?
Yeah, so it's basically like a subcategory within electrical engineering. So we have for the complete first year was similar to electrical engineering. So we had a lot of basic circuits, analog circuits, where we looked at transistors, op amps, everything, and programming as well. We did some C++ and C# programming. And what sort of differentiates the automation aspect is we have a lot of control theory. So we look at lag lead controllers, PID controllers, which is really interesting. I actually looking for a project that could use a PID controller, and it's very much hands-on. We have labs almost every other week, and first year it was each week we had these labs where we showed up and had to do some practical work, either with circuits or oscilloscopes and stuff like that. So it's very much hands-on.
That's cool. And what year are you in now? How long have you been going to? It's college, I'm assuming, or university?
Yeah, college, exactly. Okay. Yeah, so I'm second year now. Okay. So I'm starting to gain some of the expertise or specialization that differentiates automation from regular electrical engineering.
That's cool. And have the classes helped you with the projects you're working on, like the code and stuff like that?
Oh yeah, definitely. But not in the way I expected, because the way I do, or the projects I do as a hobby and what we learn in class is not really that much of the same type of stuff. But what I use almost every day from classes is the basic stuff and what to focus on when doing new projects. So I can read through data sheets a lot easier now because I know what to focus on, what information I'm looking at and what can be filtered out. I didn't know that at all before I started studying this stuff.
That's so cool.
And programming as well. I just learned by myself. So I wrote a lot of spaghetti code in the beginning, a lot of copy and paste, but now it's like much cleaner. I follow like these unwritten rules of programming, camel case, and use a lot of functions, all that stuff.
Well, I tell you what, I really appreciate you taking the time to talk, and this was just very interesting to learn about these projects. Is there a project you're working on right now? Like, do you have plans in the future for another project, or?
Yeah, actually, I'm working on right now a Bluetooth headset adapter. So I'm basically done with this. Video is probably coming up next week or something like that. So it's basically like just a Bluetooth adapter for wired headsets. It's about the same size as a USB drive, and I just fasten it on the side of my headset with magnets. So it's like it doesn't take up much space. It just hangs there, and I also cut the wire from my headset and solder it much shorter. So it's like a true wireless experience without the hassle, you know.
So it's just so I'm clear, it's like you've taken a normal headset and you've hooked it up to a Bluetooth controller?
Yeah, exactly.
Okay.
And the Bluetooth controller or Bluetooth receiver has a female audio jack as well, so I can use it with any headset I like, or like stereos or whatever.
Oh, okay, that's awesome. I see what you're saying. Then so you just plug your headphones right into it, and then okay, I gotcha.
Yeah, exactly. You see, all these phone manufacturers are starting to take away our audio jack, so I had to do something about it.
Yeah, no kidding. That's kind of crazy. Well, cool. Hey, fantastic, Eirik. I appreciate you so much for taking the time to talk. Thank you.
Yeah, thanks for having me, Michael.
Absolutely. Well, hey, I hope you enjoyed the show. I know I sure did. Eirik is up to a lot of cool stuff, and I'm sure there's a lot of cool stuff in the future, too. And I highly recommend, man, check out the code he's written. Check out, the comments he's written to try to follow along with the code. Again, if you're trying to learn this stuff, trying to understand programming and these Arduino programs, it can really help to just peruse what other people are doing. And, when you put your code out there online, you're kind of putting yourself out there. You're kind of concerned like, did I do this right? Did I not do this right? And that's there is no real, like, quote unquote, right way. I think there's better ways and cleaner ways maybe, but you got to sometimes just put yourself out there, and that's how you're going to grow. God knows I try to hide my code in the closet sometimes because I think, oh, geez, this is just trash. But, that's just what it takes. If you're not writing the code, then it's going to be a hard time learning it. All right. Well, hey, thanks so much for taking the time and listening today. If you enjoyed the show, I would love for you to rate and review us in iTunes or whatever podcast player you use, and subscribe if you're interested. So thanks again. And I hope you have a wonderful week. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino Crash Course, a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.